Could you explain why it's so difficult to say if I open it in 2018 and somehow if I open it later in 2019, is there a problem?
It's not me, it's not the library's fault or Unitec's fault, it's just that Autodesk are developing ways of making life difficult if you don't pay for upgrades, right? As students, you're okay, you get a free copy, it's sitting there right now. The only difference is that 18 runs on a pretty basic warehouse computer, 19 needs a slightly better spec. I found that out myself when I had to mark in semester 1. I was going overseas for a few days and I wanted to mark at the same time. And I purchased a little laptop which didn't have the run to work 19 very well. So yeah, that's the reason. So what it does is, it will allow you to open it, but it kind of only opens the bits that 18 understands. So if you've been doing, say, just a line from here to here to here on a layer called layer 2 or something, and a colour white, then you've probably not got a problem with that. But if you start doing any new functionalities, which you guys can do easily accidentally, then 18 might say, hey, don't understand that. Yeah. And unfortunately it doesn't give you much of a message either. I think it does tell you it's been opened on a previous version. Yeah. So today's class, we're going to go over a number of things. Very poignant for the surveyors this week, because we're going to be talking about roading. This will also be in the test, a lot of the material today, in terms of multi-choice questions. When I say it will already be in the test, it's part of my questions. You'll only get chosen between 10 and 12 of the multi-choice out of 120 something I've now got in there. I think of one and I quickly added in every year, 2 or 3 new ones. So yeah, this makes for what we call good test tucker. Put it in another way, you are advised to revise this section and read through it. Secondly, we talk about roading as opposed to platforms, which is what the civil engineers and the surveyors are doing this year as assignment 1 and 2. Surveyors will go on to do a roading project for assignment 3 and 4. Similar in some ways to the platform, but there are distinctions, and similar in some ways, except for they'll get less marks for the likes of the existing site plan, etc., because they would have already got some feedback on that and they'll know ways that they have to improve it. A lot more cross sections, a hell of a lot more, at least 11 of them compared with the 2 that you're drawing up for the first assignment. So the swings and roundabouts. As far as the engineers go, what happens is you guys go on to do a subject called project, I think, in the last year here. And every year Hugh gives you a curved road to do a long section. And somehow students go, we don't know how to do long sections, right? Well, as a first hint, if it's curved, you turn it into a P-line and then you divide it into whatever the offset should be, 5, 10, 15 metres, and you can then lay it out nice and flat as a long section like I've drawn. The only difference is Hugh's road's got a curve in it, mine's a straight one. So it's exactly the same techniques, exactly the same stretch technique, everything. But of course, you still get students who have not done this themselves and they will find it very hard in the project. So that's the reason why this is a prerequisite. With surveying, you'll probably, unless you're in a small company, you'll probably never get to design a road as such or a platform, but you will have to set it out. And it's super important that you know a lot of this terminology. It's really, really critical to your studies. Like, for example, if they say please go and set out the berm along the side of the road, etc. You can't just sit there looking blankly when you're in a job. You've got to take your survey equipment out and pick up the berm or the batter slope, etc., etc. So there are a few surveying things in this as well, which I'll point out. I'll also go on to do some examples, and there will be examples of cross sections. So we're on cross sections this week, and I'll show you some roading cross sections, which the surveyors should take note, because we're going to go into that a bit more deeper in semester 2. And I'll show you some typical platform cross sections. I'll draw a picture on the board here in the lab as to what surprise I've got coming up as well, which will lead us into next week's lecture. And I really want to highlight the difference between cross sections and long sections. There's a big, big difference when you come to draw them up. So it's important that you note that down or make sure you revise the video. So many students don't, and so many wonder why they don't get a good mark for their cross sections in the next section. So we are talking about assignment 2, and I got a good question about that from a student over the last week. The notes that you make, yes, I've said you only need 7 notes on this existing site plan and on the long section. Yes, you can copy some of the notes onto the long section. So how easy is that? I've given you at least 2 notes. This drawing is in metres, and a note about the survey coordinates. I also went on about the trees, the environmental, the wetlands, the silt, the time of the year, blah, blah, blah. Pretty much gave you the notes. The problem you've got is that if you don't do 14 odd notes, you won't have a good basis in assignment 2 for your design statement. Design statement, I'm expecting 3 paragraphs. One is talking about the site, explaining it, all the mathematical things you're doing. 2, the many issues that are involved with this site. And 3, some ways around some of the problems. So that's quite a bit. It's probably the equivalent of about half to a full page. And if you've only written 7 notes, you're going to struggle with that. But if you've written 14 notes, you pretty much can go copy, paste, and you've got the start of your work. Now that's only worth 2 marks, but I'm expecting at least half a page, maybe a full page to get that. Okay? Now that, if you haven't noticed, that is part of assignment 2. I'm only going to say this once in this lecture, so I'm looking at all the cameras. You must put that in a text box on Moodle. You'll notice assignment 2 has got a text box which you can type into. You can revise it, you can delete it, you can copy from Word in there, and then you can go, oh, so I would have a Word document and go, oh no, I want to add to that. Then delete and paste into this text box. It is not a Word doc. I do not want a Word document. I do not want a PDF. I do not want anything sent to me on email. I want to put in the text box of Moodle. You don't do that, you don't get your 2 marks. Simple as. Yep.
How do you do that?
When you go to open up assignment, I don't want to put assignment 2 Dropbox on there because we have some characters in here. We'll put assignment 1 in there, okay? So at the moment it's hidden, but you'll see when you click on it, there'll be a place to put your drawing, and there'll be a box there, and I can show you that before assignment 2 is done. Okay? So that's the way I want it. So I don't want it in the drawing, I don't want it in Word, I don't want it in PDF, I don't want anything like that. I don't want it set to my Gmail, my Unikeep mail, or any other mail. I don't want it on Facebook. I want it in a text box. It's all right. I'll still have about 20 students don't even put it in, enter it in at all. But I'm trying to help you by saying the more notes you come up with, the more ideas you'll have for that paragraph or 3 paragraphs. So that is kind of building as we go along. When we did our long section in the lab, we found out there was a little bit of an issue around the outlet, and also back up where the manhole was. It was quite a shallow manhole. Plus, there's a pipe under a pipe going into the manhole. So there's a few things going on that are building as well in the background, which will be more notes. So when we come to do our cross sections, we're going to find more issues. Okay? And yeah, feel free, ask me about them when you draw them. Hey, Roger, my cross section, I've just noticed that the trees, the batter slopes are going down under the drip line of the tree. Can I do this? The answer would be no. You need to figure out what you're going to do. Can you chop the tree down? Or if it's a native, could you possibly put a retaining wall there? Cheapest option is to apply for resource consent. A couple of $100, yes or no, gone. Second cheapest option is if the geotechnical engineer won't let you change the batter slope, then you're going to have to put a retaining wall there. Once again, you're not engineers who design that. The surveyors definitely aren't. So you need to put a note saying engineer to design retaining wall. Structure engineering, very good, well done. Yeah. That said, if it's a small one, 300, 400, 500, that's fine. You can design it. You have some privileges. You get to 1.5 metres, and that's too high. That can kill someone. I was saying to a person in class, just because I'm a big guy doesn't mean to say I can't get squashed by it. I could be bending over doing up my shoelaces, bang. Okay? So it's all relative, and it needs proper design. So we're going to go through, I'll start by looking at the cross sections with respect to the volumes. I will talk about what we're going to be doing roughly, but next week we're going to be covering volumes in detail, and I'm going to tell you exactly what we're going to be doing for the assignment 2. By the way, the surveyors will have to do it on the road, a roading project, so it's doubly important that you take note of what I'm talking about. And we'll talk about road design, roading terms, canvas, super elevation, cross sections, and I'll give you a few examples. So, yeah, let's rock and roll. So we'll start with the very last page of note 3 notes. And I just wanted to make sure that you were all reading these. First of all, the long section. It isn't just a case of drawing the lines that we drew up in class. This is a general tick list. So you can go through and go, you might go, okay, there's no environmental concerns, don't worry about that. Or you might go, yes, there is. I need to include that in my notes or include it on the drawing itself. Right the way through to what should you be showing on there in terms of the drawing. Remember, as a big hint, the racing driver that threw away his rear screen mirror because he wasn't interested in anything behind his car, exactly like that with the long section, okay? A lot of students have been asking me how many trees do I draw in there, what about the ones in front, blah, blah, blah. It's all about the long section along the pipe. You should have learnt that last year. If you're unsure about it, go back and have a look at week 2 or 3 notes from last year's when you did that sketch drawing through the long section. When it comes to the existing plan, there's a number of other things there that you should just go through and make sure. This isn't a complete list, but it's a pretty much an 80 or 90% list for a tick off. There are other things here and there. Student asked me if they need to put the path on. Of course you do. If it cuts through it, yes. If it doesn't, no. There's a few other things as well. For example, the bush area. It's kind of in the background, but it's fairly close. But being kind of native bush or whatever, I think it's important to at least show it on the long section because it's kind of over there. But I wouldn't go any further than that, like, you know, to the marae or to the rugby grounds or on and on and on, straight out. Just the fact that that bush is fairly close.
More than a little bit.
Probably, yeah. The other thing that some people are getting a little bit concerned about is that they go onto Google and a couple of things don't quite look right. This is a project that's been developed over I can't put the actual survey on there because it's too easy to obtain the contours and get everything perfect. So I've tweaked things around. So yes, they aren't right. And yes, it's flat out there, but somehow Roger's done the contours coming up a bit more than they should. You have to accept that. It's also towards the project for the surveyors as well. And you are expected, if buildings have been called up, to put at least a very approximate outline of the building and call it approximate. Please, surveyors, do not get out your survey equipment and do it down to the last millimetre. I don't want that. You know, just step it out, or maybe just trace it off a Google map. Maybe measure it and go, okay, it's about 10 metres, so just draw a line of 10 metres, okay? The IBM building is incorrectly labelled. Most of you know that anyway. It's called Concentrix now. A couple of years ago it was called IBM. A couple of years before that it's called the Business School. So changes like the wind. So you'll see it on Google anyway. And that curved area is a pathed area. So just an approximate line. And there are 3 buildings which need the symbol that we mentioned in week 1. Okay, moving on to cross sections. You'll notice with grading cross sections, we always start here at the bottom left, and we work our way up as we drive along the road. So technically, back in the old days, we used to put all the road cross sections in a great big line in the meeting room, and we almost like drive along them. Well, programs now will allow you to do that now. 12D, for example, when you've done your design, will allow you to drive through it, and there are other programs that tack onto that which allow you to drive through it at whatever speed you want. So, yeah, the programs like that are getting more and more complex, but at the end of the day, they still have to produce cross sections to build them. Like I said in the lab, cross sections are 1-to-1. They're exactly as it is. So as you're walking along the road, you can carry your plans with you. Yes, yes. Oh, what's that doing there? It's a jersey. What's that doing on my cross section? maybe that's wrong, sort of thing, okay? Or, oh, there's a cliff. It gets more critical when a surveyor does not pick up something. So he might be asked to do a road every 5, 10, the norm is 20 metres, and he completely ignores a great big rock outcrop. Now, if you do that in central Otago, that's dynamite territory. You need dynamite to get rid of the schist rock. And if you ignore that as a surveyor and just move on to the next cross section, you've ignored quite a few $100,000 worth of work, right? Just like if you ignore a great big hole in the ground. So one of my questions in the test is, why would a surveyor pick up an extra cross section on a road job? What would be the reason for actually taking an in-between cross section? And you guys are noticing on the long section, when we do every 5 metres, there are other ones as well, like the platform, the path, trees, etc. So, yeah, with cross sections, we build off them, we use them on site. Project managers, future project managers used it, will be using them all the time. And so it's important to put as much information as you can. So there's the first difference. The fact that they're one-to-one and they're used more predominantly on site. The long section is kind of laid out in the office, gives everyone a rough idea of the road. Remember, it's stretched. We do other things for long sections, but the other thing is with cross sections, they're normally at a different scale, a bigger scale, so we can see them better. So I've made you do that with your platforms. And when we do the roading job, they'll also be at a different scale. How many do we put on a sheet? Well, that is determined by you, basically, the draftsman, the designer. In this case, we got 6 on. That's probably a reasonable amount at a scale of 1 to 100. If it was a scale of 1 to 50, we might only get 4. So as I said, we always go up, so change 0, 5, 10, 15, 20, 25, and there was another sheet of these as well. Surveyors would probably do 2 sheets of cross sections, maybe 3. We always have notes on there, we have symbols on there, but there is a very big difference in terms of things like the trees that you put on your long section, because they're going to be squashed down. The other thing is, on cross sections we need a point of reference. So on a normal country road, it is normally the centre of the road, which in my surveying days brings back a little story. I remember there was a guy in Dunedin, he's retired now, but his name was the Hat. And surveying equipment back in those days was worth a hell of a lot of money. It is still worth money, but it's nowhere near as much. And if you damaged something, even if it was a staff or something like that, you know, you had to report to the Hat. He was in charge of the whole district. And going into his office was hell, let alone if you'd done something wrong. He had this bowler hat that he used to hang up on the wall, and when he had it on, you knew you were in trouble. Anyway, we had a team of guys that set up in the middle of the road. They put all their cones out, warning the cars that there was a survey there, and they had the tripod set up with the theodolite on top, and they decided to have a lunch break. They were sitting there eating their lunch, and this car came around the corner, ignoring all the signs, straight through the theodolite, smashed it to bits, and they thought, oh well, the Hat won't be too bad because no one was killed in the incident. They could have been working there. Well, he just went ballistic at them. He said, I don't want any survey equipment broken unless the surveyor is broken at the same time. Always remember that. Which leads me on to the other surveyor, another surveyor I was involved with. I wasn't on the job. State Highway 1, when they extended by Green Lane there. Obviously, the line of reference wasn't the centre of the road. I mean, unless you really don't like your chainmen, you put them out in the centre of the road, dodging traffic. So you make a line of reference on the side of the road. Country roads like that one where that survey equipment was had no problem. You go along the centre, you set up at each station. when we draw the cross sections, we draw them up with the centre line being the point of reference on most roads and on your platform. Anything to the left, we start doing our distance or change it, or call it distance to the left. Anything to the right, to the right. So this centre line becomes 0. Now that's quite different to the long section. Long section, the 0 was at this end, isn't it? Yeah. Okay? So there's a second difference in cross sections. Thirdly, the batter slopes will be back to 1:1. And fourthly, if we change our scale, our text and our arrows are going to change back to another size. And I don't want emails saying, oh, what's the size of the text? Is it 0.35? Is it 0.7? Blah, blah, blah. On the very first lecture, over here on this board, a little bit to this still here, is the calculation that I did for the text heights. Please apply that to the new cross section at 1 to 50, not 1 to 100. I'm sure you all know what I'm talking about.
Is
If
it
you
for
took,
the
I beg your pardon?
for the long section as well?
The long section is 1 to 100, so the text heights will be the same as the existing site plan. It's just that this is assignment 2 we're talking about now. I know it's hard. Most lecturers will do a block of work and you'll hand in, and then the next week they'll start on the next assignment, and then you hand in, and then so on. We've moved on. All right? So long section was in the past. Yep.
Isn't it butterfly cattle fill type thing, is that on assignment 1?
No. Please don't draw that on the existing site plan. And please don't put your section marks on there either for the cross sections or long sections. Yeah, the butterfly wings, you will copy that to the side. Now technically you've moved the coordinates for your proposed plan. In the real world, we leave it on top because we don't want to destroy the survey data. We just put different layers on there and turn them off in different viewports. But I would rather, to not confuse you guys, just copy it to the side and start drawing it over here. Now if you hand in on Sunday and you've started that, I don't care. I won't be marking that, alright? Just pretend it's not even there. You've started your cross section, that's fine with me. I'm marking your existing site plan, alright? So that allows you to do that. I will, as soon as that Dropbox closes, sometime on a Sunday, Monday, I'll make the next assignment to Dropbox available. I've just learned from mistakes. Honestly, if I open it up, we have issues. And the issues start happening because students then go into assignment 2 and delete the one they put in there for assignment 1 accidentally and put their new assignment 2 in there. And I'm like, what's happened here? So if I put it all in one box, we'll be fine. And that reminds me, in week 7, there'll be a separate box for the survey. And there will be a penalty for engineers that put their assignment in there and surveyors that put their assignment in the other box. All right? Because that becomes a problem for me. I don't like problems. I like fishing.
I like fishing too.
Was that a hint to go out with me in the boat? Okay, overview. There's a few little hand sketches I've left in here. I could draw them up on AutoCAD, but they're the sort of things that site engineers tend to do. And they'll do these little sketches just so that when they're setting up the road or they're supervising, they know what's going on. So there's a bit of terminology coming up here, and please put your hand up and ask if there's something you don't quite understand. CL is common for centre line, and we do a centre line type when we do a road cross section. It's also common to have a drain over here. When we talk about the pavement, it's the area where we start building up the sub-base, the base course, and then the tar seal layer. Surveyors are often asked to go out and measure each one of those layers, and it's quite critical because the contractors will be trying to get away with as much as they can, trying to get away as thin a layer as they can, because the more they get away with, the more profit they've made. Surveyors are often on roading jobs out there every day measuring up every metre as they're going along the road. Also, there are various engineering tests that surveyors get involved with, which is they drop weights onto the road to see how far it penetrates, whether the compaction's good enough or not, etc. The other thing is the positioning of the road. It's very easy to end up making roads wider or smaller, and once again, surveyors on roading jobs are there the whole time, keeping an eye on all that sort of thing. So they need a very good background on these terminologies. The formation is basically what the width of our platform, and then it goes on to the batter slopes. The pavement different. In our engineering project, we would assume the pavement won't be a road pavement, it will be a concrete slab, and we're going to do a building on top of that. So it's a little bit different, but in a roading project, it's called a pavement. The next lot of notes goes on to talk about basically the history of surveying and roading. I won't bore you too much. You're all capable of reading this. I have asked a few questions, multi-choice from this, but it should be noted that today we have programs like 12D, Civil 3D is a popular one too, MX Roads, which is the motorway design package, and they're all very capable of inputting surveys, and they're all very capable of doing exactly what you guys are doing on your roading jobs, on a roading job or a platform job. They're also capable of taking long sections, cross sections, and volumes. The problem is that not everything is on a digital base. Sometimes it is, like you got your CAD file, but it's not 3D. So it needs to either be turned into 3D or you need to manually draw these things up. Small jobs like the one I've given you would probably be manually drawn. Larger jobs would probably be a digital base. But then there's the next problem. The guys on site don't have these programs. So they're sitting there with a 2018, maybe 15 copy of AutoCAD on their computers. And they're opening up files that they get sent, and the best they can do is maybe read them and work out what's going on from there. So they don't have that ability to walk through the job in 3D. A lot of you guys and girls are going to end up site engineers. You're going to have to be able to read 2D drawings and figure out what's happening in 3D. It's not easy, but it's something that you will be needing to do. So, in terms of surveying, back in the 1900s and 1960s, the most common form of surveying was an ABNY level. And it sounds very old and old-fashioned, but the thing was about the same size as this duster. And it had a bubble on this part, and you adjusted that bit there, and it had a sight on it that you could look through. And it was only very small. You could put it in a backpack. So if you were walking over hills like this, it was very easy to survey that, even if it was covered in thick bush. Because you could start walking up here, you would put, both of you had a post about I think it was 1.5 high, and you had a tape measure. And in essence, what you were doing was you were measuring that distance, 120.3, and you had an angle here which might be 3.5 degrees. And then you would take your next shot and move on, and so on and so forth. Normally, if you're going through thick bush, you have a bushwhacker that you're clearing it with, so you've got that in your hand, And so to carry just a stick at an Abney level was very quick and a very accurate way of doing it, really, for those days. You think of taking total stations up through the bush, carrying that in a backpack. You know, it's a surveyor is still way down the bottom of the hill taking his first 3 shots. And you've gone over 2 hills with the Abney level, and you've got a very good idea of what the countryside's like. Now that works pretty good for schematics, old country roads, tracks up to windmills, things like that. But then when you are going to need more accurate readings, then of course you're going to have to use your survey equipment. So the Abney got blasted away around about the 1980s by prisms, total stations and all the digital stuff. The on-lights changed. And of course the staff and level, or staff, level and tape were also another way that we used. And then around about the 1980s, when I came on board at surveying, we had the total stations. There's a bit of overlap I wanted to sit then, and stuff was starting to be imported into a program called CivilCAD, which was the very first program for doing this sort of work, pretty basic. That was slowly getting developed in the background to what you see now in surveying, but also what was happening was digital data was becoming more prominent. They were doing flyovers over Auckland in the 80s, and they were doing contours of those. So as that increased, they were getting more and more accurate. The problem was that the height of the trees. So if it was like a forest of pine trees where they all grow the same length, it's very easy. You just take that off and you've got the ground profile. But when it's kind of New Zealand native bush with different heights of trees and things, the accuracy disappeared if you were doing a job like, say, the motorway north of Auckland now, which they're extending. That was through some fairly deep dense bush up through that way as well. And then, of course, between 2000 and 2014, they started developing higher levels of accuracy of the satellite data came into play, and a thing called LiDAR. And of course, more recently, drone surveys, which I think, in my opinion, I said this about 10 years ago, I think drones will start to take over. I think surveyors will end up, apart from legal surveys, I think they'll end up being almost like drone operators. I think they'll do a lot of their work from the office. I can sort of see a day when that's the way it's going to happen. So that's kind of a little bit of a basic history of surveying. And there's a little bit of explanation about LiDAR. By memory, there's no questions on LiDAR in the test. It's more of an information, gone a little bit further than I need to. But what is important is actually knowing what survey you want to do. So as an engineer, you're going to have to decide, well, what's my budget? How accurate does it need to be? And how can I get around paying millions of dollars for a surveyor if I can actually just take it off aerial photographs? So a lot of those questions you have to answer yourself according to what the client wants. Oops. That wasn't the cell phone, was it? Oh. Okay, so there's some examples here of a job. Job 1, steep terrain, involves a platform for a large wind farm for rough gravel road to the site. So I did that at a job down by Raglan where they were doing their wind farm down there. And we worked out that we could use the aerial photography to do an approximate gravel road up to the job. And it worked out all right. It was a little bit different in a couple of places. The guy on site managed to get around that, and we saved a lot of money on the survey. Job 2, a highway shape correction. Well, you can't save any money on that. You're talking about a digital site survey with accurate levels from a survey company. Because you're changing the correction of the road, the camber of the road, that requires good digital data. And there are questions around the same as those two there with job 1 and job 2. There's some common scales here. Now, I'd like to talk about batter slopes for a little bit. And this is the first time my friend, the geotechnical engineer, comes into play. He was always the most unpopular one in the office. He was always the first in. No one ever knew that he ever went home. And no one really talked to him because he was the one that stuffed up most of your jobs. I'll tell you why in a minute. With roading jobs, you've got your areas of cut. That's my car, by the way. Nice, eh? Yeah. And so that's an area of fill. No one hit me up on that. A good chance to earn half a mark there, never mind. Okay, and so we have an area of fill and an area of cut. So along the road, our job was normally from the start of the new piece of road to the end to what they call balance the quantities. So we would go along the road. That was the new road that we did. We'd work out the quantities, and we might have, say, too much cut. By the way, these are questions also in the test. So one way of balancing it so we had less cut, an obvious way was to drop down the road here like this. So when you drop the level of the road down, sorry, did I say cut? Less cut, you raise the road. You raise it in fill. And you, obviously to be raised here as well. So we have less cut and we have more fill. So therefore the balance comes back to zero again. Another way of doing it is, might have another colour here, yeah, I do, is to increase the batter slopes in the cut, in the fill, and to decrease the batter slope in the cut. So if we decrease the batter slope in the cut, we have less cut. We increase it in the fill, we're getting more fill, so therefore the overall balance works out as well. And the opposite can be applied if we want more fill. Less fill. If we want less fill, we drop the level of the road, or we increase the level of the fill batter, or we drop the level of the road will mean there's more cut, or we increase the cut batter. And here, we used to do that all the time. We would do those different ideas all the time to balance our cut and the fill. Why? Because if you balance your cut and the fill along a road job, say it's 1 kilometre, you don't have to get the fill from anywhere else. You don't have to, you're using the same cut as you're going along the road, okay? So obviously you need to plan it, so you cut first and then you patch up the areas of fill, then you cut again. But if you've got a balance at the end of a road job, you've done a good job, all right? Yeah.
Is that drone the upper one, like, that's filling, right?
Yeah, so this is fill.
And down one, it's filling too. That's not balancing.
No, this is cut, yeah. Technically that.
Oh, okay, that's the level.
Yeah.
All right.
Yeah, so you've got to think of this as a big long road. Some pieces are cut, like when you go north of Auckland before you get to the tunnel, there's those big batter slopes, that's cut. And sometimes you're driving along, you're looking down, oh, that's a big bank, you don't want to fall down there, okay, that's this one. So what I'm trying to say is to balance our cut and our fill, we have those different techniques, increasing the batter or decreasing batter, raising the height, lowering the height. Okay, yeah.
Can you please draw formation level in these two? Draw.
Formation level is, the first formation level of my design would be this one here. And this one here. Right? That's the road, that's my new road. I put the car there just so you get an idea of what the formation level is, right? The problem is that you spend days, weeks designing the road, balancing the cut and fills. Everybody's happy, signed up by my boss, about to go out the door, and then all of a sudden the geotechnical engineer wakes up. Normally they've got big bushy beards and they haven't shaved or washed for about 4 days. And that's just the females. They're very annoying because they walk into the office and they go, and they scratch their head and they go, "I'll change that batter slope, please."
Retaining wall.
Yeah. Not 2 to 1, make it maybe 2.5 to 1, not 1 to 1, make it 0.9 to 1. And then they walk away again and they sit down and you don't see them again. And you're like, because your balances are completely out of gear. So then you've got to do something else for the job, and then they can come in right at the last minute with Friday deadline and, 4 o'clock on a Friday, change the batter slope. So that's why they're not so popular.
Such a great people.
Yeah, yeah. I did relate to there was a horrible story 2 years ago. There was some guy actually died in an office, wasn't in New Zealand, and they never realised he was dead for 2 days, which is pretty sad. And then I thought, oh no, it could be a geotechnical engineer. You guys are going to wonder why I don't like geotechnical engineering.
Roger.
Yep, sure.
From a financial viewpoint, when we're doing fills and cuts, what do the construction companies prefer, more fill or more cut, or are the aggregates the same, so it doesn't really matter?
Well, the idea is to try and balance it so that it is the
Doesn't
same.
matter which one.
Good point though. A job like here at Unitech, and here's another note for you guys as well. You're talking about wetlands, you're talking about the water being very sacred to the Maoris, or the local iwi, sorry. So with that in mind, bringing anything extra onto site, it would have to be washed, clean and proper engineering bill, approved by everybody, right? So you'd need to tick in the box from the Greens, you'd need to tick in the box from the iwi, you'd need to tick in the box from an engineer on site to make sure it can be properly compacted. So you can't just take some fill, bit of old concrete and tube or whatever it's in someone's backyard and throw it in there. So that means cost. And once you're getting proper fill like that that's clean, you're going to quarries, and they're quite a long way away. And as we all know, driving around Auckland isn't fun. Once you get past about 7 o'clock in the morning and all the way through to about 7 at night before you can start moving again. So that costs money. Trucking companies, haulage, they have to take that into account. So it costs more and more to deliver. Then you've got the other scenario of digging it out and getting rid of it. And that is even bigger. So that cost, at this time of the year, well, we all know what it's like walking on your grass at home. It's all, right? Well, that's what, farmers don't want trucks anywhere near their property. Go back summer, if they want a bit filled in, yep, come, open the gates up. You can dump here, no problem. Don't care what it is, as long as it's got a bit of dirt in it, we'll be fine. But the minute that the tyres are getting stuck and whatever, he has to stop, get his tractor out, they just close the gate. No dumping here. So therefore your dump sites are north of Albany and often quite south of the Bombays. That's a long way to drive just to get rid of one truckload of dirt. So cost escalates. Yeah. The other scenarios is you order it all at once, you order all your fill at once, you get it to Unitech and there's nowhere to put it because they haven't started their cutting yet. So they're all lined up down Carrington Road waiting to dump, and you're sitting there as site manager going, oh, I forgot about that. So where do you put it? No, you don't put it on top of the CEO's office, or mine. You've got to find somewhere to put it. So Yeah, back to what we were talking about, there was one time when we checkmated the geotechnical engineer, and I have to relay this one to you, see might get quite passionate about this. We had a job where we designed a job, sort of something like that, with your car sitting there, and it was quite a steep bank.
Oh, that's a car.
That's a car, it's not very good. You guys are students, you can relate to a car looking like that.
Oh, that's a robot.
Yeah, okay. So what, I can't sketch cars, right. The geotechnical engineer came out of his little hole, it was a he, and he said, no, you can't do that, I want a better slope that look like that. All right? And you're like, oh my goodness, you're just thinking dollars, dollars, dollars. First of all, you got to cut it out. Secondly, you got to get rid of it. Blah blah blah. And it was along most of the road. It was very much like that all the way. And I'm sitting there going, oh, I'm going to have to tell my boss. And I told my boss, and he stood there for a minute, and he said, what about benching? And benching is where you do this. And benching has the advantage of letting you do it steeper. Okay? So, okay, there are some additional costs in drainage at each point, but it allows you to do a lot steeper, better slopes. Some examples might be going over the Kaimais to Tauranga. You'll see benching all the way up there on a steep slope. And it does depend on what type you've got. But I remember watching the face of the geotechnical engineer drop, and he went back to his desk because our benching ended up being about the same cost as the batter slope. So you can get around it. Because of that, it's a question in the test. And we talk about benching here. Benching is often advisable in cuttings. 3 metres wide benches every 6.1 metres of vertical height is a common practice.
Which one's better?
Well, if you do this, definitely this. I've only sketched that. You might even get away with steeper. You might even get away with something like that. Which means you've got no earthworks at all to do, you know. Okay? You follow the line of the existing ground. There's some typical cut and fill batters as well. Now we're going to keep talking about my geotechnical engineer next week when it comes to volumes, because that also affected our volumes calculations. Anyone that's done any geotechnical engineering will know that every soil, has a different compaction factor, and we'll talk about the compaction factors and relate that also to working out our volumes. In fact, it's probably quite a good time to refer back to a little drawing here, this one here. So next week we're going to be looking at this in more detail, and the way how we do volumes is, first of all, we work out the cross-sectional areas. By the way, that's the fifth thing that's different on your cross-sections. You can't really do an area for your cut and fill on your long section because it's got a stretched vertical, and because the vertical's been stretched, the area means nothing. But on the cross-sections, the areas are 1-to-1, so they are perfect. So we should include the areas of cut and fill on our cross-sections. Each one. Surveyors take note, we've got 11 of them to do. Okay, now having said that, the engineers and surveyors for project 1 and 2, here's our platform. Let's just say that our fill is like that and our cut is like that. This is only an example. I haven't actually done the exercise yet. Let's just say it's like that. Then, in order to do a volume, you're going to need, well, you already will be doing this one through the middle of the platform. So you've got one done. But I would like to see you do, actually, which way will we do them? Do them this way. The good news is I only want to see a little drawing like that. That's all. Each time you do a section. Now, from Ingrid's class, if you draw around here, you can work out an area. You know that, don't you, with the P-line? So, as you do each one of these sections, it'll give you a different area. And you can work out a chainage along here, starting from one end. 1, that might be 2 meters, that might be 5, that might be 6, that might be 8, that might be 10.5, it might be 11 or something like that. So you've got a chainage as you work your way along. So it's a bit like those sections I showed you of the road. And the way how we work out our volumes is we have a distance between each one. We have an area of each one. And we can work out our cubic meters from that. It's not quite as easy as that. I will introduce you next week to the Prismordial calculation sheet, my famous one. You'll get to take it home in a spreadsheet. And when we enter these values into it, it pops out an overall volume. It's the same formula on that sheet that 12D uses, Civil 3D and MX Road. But what I'm giving you a bit of pre-warning to is I'll go over this in more detail next week. In order to calculate the volumes, it's worth 2 marks. And we'll show you that as well next week. You will need to do these little sketches, about 8 of them, with the volumes under each one. And then you'll need to put it into the Prismordial calculation sheet and put that, copy-paste that into your drawing. Therefore, I will be able to check that and check that you've done the calculate the little drawings like that correctly. Please don't get that confused with the 2 cross sections you need to do. I want 2 very detailed cross sections, trees, platform, cut, fill, all that sort of stuff on it. But these little ones, which you didn't know you had to do till this week, is what we're also going to be showing you next week. Do you understand that?
Excuse me.
Yep. Simon, 2.
Is there any computer program that uses kind of integration or integral to use that volume?
To get this volume up here? Yes, it's a spreadsheet, which I'm going to give you. You put the values into the spreadsheet, and it gives you an overall volume cut or fill.
On Excel?
Yeah. Don't worry, it's not as easy as you think. But the good thing is I make you remember the formula for the test. Okay, so some of the things I talked about here, I've also put in an explanation format, and I've also put it in a, I'm sorry, I'll go on to the actual, here it is. I've got a whole list of terminology, which is very good questions for the test. And some of the things I've talked about, for example, there goes the benching. And another one which is very important as far as I'm concerned with roads is the berm or the side of the road. And even more important is the shoulder. So there's some little sketches here that go with each one, and there's some explanations of the different things. Some of these I've questioned in the test, some of them I haven't. Now I want to talk briefly about the shoulder of a road. The shoulder of the road is probably the most important structural part of the road. A lot of people think it's just there in case you have a flat tyre, or in case you have to pull over and there's an accident and an ambulance can drive along it, or a tow truck. It's actually there for the strength and the integrity of the whole road. Without the shoulder, the road will start to disappear down the bank or into the side drain. Sometimes you'll see a truck lying on its side and you go, how the hell did that happen? What sort of guy would drive a truck on a straight road and then just woof, flick it onto its side? It's not the truck driver's fault, it's the fault of the road design, because the shoulder has given way. And see, cars don't make a lot of difference to our roads, it's the heavier vehicles that do. And he's parked or he's pulled over to the side and bang, the whole lot's gone down the side of the road and flipped him. So next time you're trying to pass a truck and you're getting really frustrated with him because he's not going as far to the edge as he could, there's a very good reason for that. So the shoulder of a road, and this is one of my multi-choice questions, is all to do with strength. So I'll throw answers in there like a good place to park if you have a breakdown. Yes, it is, but it's not the main reason for it. And also for emergency vehicles, etc. So you kind of, when you're designing a road, you work backwards from the shoulder, because you need the same strength all the way to the edge of the shoulder, which basically is the edge of the cutting for a platform or for a road. So therefore the geotechnical engineer's got all the rights to go right to the edge with this design before he comes up with a ballast slope design. Crossfall's an interesting one. I'll go back to this sketch here. One or two you might have an interest in cars. Obviously I don't. I sort of drawn you a good one. But I do occasionally watch shows at Dixon, going round and around the track, making you giddy. Those tracks, just like the bike tracks in the Olympics, they always have a very good circular curve on them, and a very good camber on the road. And you'll notice that the camber starts at about 3 degrees both ways. Then it works its way to a situation where it's got a full camber from here to here, and then it'll go back to its -3 degrees on both sides. And that is basically goes from the start of a circular curve to the end of a circular curve. On more complex roads like motorways, we have a spiral curve leading into the circular curve. Engineers will go on to do that in highway design, motorway design as well. But that's just a basic drawing introducing you to super elevation and camber. Okay. There's various little sketches there, pretty much repeating and covering things. One thing that I'd like to point out here with this sketch is we normally have a subsoil drain under roads. So if you're ever in an office drawing up these typical sections, you need to include a subsoil drain. Now, I haven't decided yet, but I may get the surveyors to do something like this, which would be classed as a typical cross-section, because when you do road design, normally they do a typical cross-section in detail to show what's actually there, and that would be a very good example of a typical road cross-section. Lastly, I've included this little sketch here. If you see a carved out piece of ground ready for a road, on the right hand side you'll normally see, or left hand side of the road to where you're driving, you'll normally see 1, 2, 3, 4 pegs. And they're the pegs the surveyors have to put in. They peg the bottom of the batter, they peg the point at which the cut and fill equal each other, and they peg the piece at the top of the batter. Bottom of the batter we know is called the toe of the fill, and the top is called the top of the cut. And there's also one last peg here, this excavation peg, which often they have a board with the angle of the cut on it as well. So I just wanted to include that, because when an engineer sends a surveyor out to do a job, that's the sort of thing that they need to see in the ground before the digger starts doing the donkey work. There's a question on that as well. Now, lastly, we'll go on to look at some examples of cross sections. I've got these in a better format to look at, so we'll open them up. Now, just remember, like all my examples, it's not perfect. You copy it, you're more likely to get about 50%. Is there anything there that stands out as being wrong right from the start? What did I tell you about the hatching?
Rocks.
Rocks. Rock conglomerate. That is not a hatch for fill. Secondly, those arrows are not the right size. So what that student did is they forgot to change the arrow size for their cross sections. Minus 0.5 AutoCAD. They haven't labelled their batter slopes properly. The two should have been on the top and the one below. And the fill should be pointing at the batter slope. At the fill. That's fine, what they've done there with the fill volume and the cut volume. And they haven't got their ground line right. They didn't look back on their techlit notes. It's on a 45-degree angle. Trees were okay because their other trees were stretched on their long section. Now, with the cross sections, a common question I get from students, I won't be getting it this year because I'll say, refer to your movie from my lecture. The common question is, how far do we take the cross sections? My answer is, as far as you like, because you're only going to get so much of it fitting onto the sheet. Now, in this case, we had an outlet, lovely outlet structure there, by the way, completely wrong. And we had a manhole, just like you guys have got, over here somewhere. Now, I said to all the students, just like I'm going to say to you, the platform and the outlet, if you can get both of those in there, then you've done your job with your cross section, okay? Platform and so the way how we cover the manhole is we do that symbol, that the students got the symbol right, so they were listening to me a little bit. That means it carries on. What the student didn't do is say to manhole 1 or A, invert level equals, lid level equals, bottom, what else we got? Bottom of manhole. Equals. So that can also be covered. You could also say C note 3 or something, and in your notes you could say manhole blah 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 blah. So you don't have to write all that on there, but you do need to manhole A or B or C on there as well. So that's what the students left off there. This height of the text is wrong, along with those arrows at each side. And look where they started the distance. Obviously not listening in class. I don't think that will get half marks. Looks pretty good when you opened it up. Lovely downloaded internet trees. I might my daughter trying to do a big picture on the front page of her English assignment in the last year at school. Wondered why she got very low marks. Lovely sketch though. Okay. Example 2. This time the student listened to me and they did the centre line. That's cool. But they didn't do a distance down the bottom. Instead they thought they could just do dimensions. No, that's wrong. So, no dimensions. All of these are sideways and they've got M after them. I didn't ask for that. Should be the other way around, not that way around. Wow, they really did like their basket weaving, didn't they? Absolutely overboard. You only need to show a little bit of it so we know where it is. So for example, here is important, plus on the other side, maybe a little bit under the pipe here and here and here. When I say a little bit, about that much. They've used the batter slope symbol there, completely wrong. It's used on the existing site plan, as per my sketch a couple of weeks ago or a week ago. Tree was wrong. They copied the tree from the along section and didn't stretch it down to the right size. And for some reason, they thought because this little triangle was very small, they were allowed to get away with very tiny text. And they did that at 1-to-1 as well, not 2-to-1. So a lot of things there that meant that even although they went through the trouble of the notes and everything else, there was a lot of imperfections with that one. Now that was a section in one direction, and by the way, there's no outlet as well. And I could keep going. On a cross section, we don't show a centre line. Not 100% true. It depends how the pipe crosses the cross section. In this case, the student just drew the line all the way, but the pipe actually crossed over the cross section like that. So the only piece that was solid was the bit where it crossed over, where you cut through the pipe. The bit behind, we're not interested in, so they shouldn't have even shown that. Where it crossed over, there should have been a centre line in both directions, like in your sketch for Ingrid in week 2. And then when it was in the distance, it was dashed with no centre line. Got that? So you had behind, show, cross through, solid, centre line in both directions, and in the ground, dashed each side, but no centre line. Example 3. Oh yeah, this is just going in the other direction. So the students made all the similar mistakes. That looks a little bit like a coconut tree, the way they've done that. I said no palms. Oh, very large text for the native tree as well. So they're examples, but they're not perfect.